When I first came across this problem, it looked at first glance to be quite easy. I thought, you just start at the 0, 0 point in the matrix and go across the first row, down the column, back from that row at the bottom up to uh, the column you're at, and then continue the traversal in a spiral fashion as you collect your values into an array. And it turns out, as you'll see, is how it plays out is it's a bit more complex than it seems at first glance. And what makes it so complex is all the moving parts. So let's see how this plays out. As always, whenever we have a grid or a matrix, we want to take the dimensions of that grid or matrix by saying mn equals len of matrix, and then len of matrix 0. So that is m by n matrix, right? Rows and columns. Then we need our resulting array, res equals the array. And here is probably the most, meticulous tools that will help you solve this problem, right? We need 3 pointers, I, j, and k. So I and j to traverse the matrix, and then k to help orient our I and j pointers. And you'll see how that plays out shortly. So first we want to traverse the first spiral in that matrix. That is, if you look in example 1, 1, 2, 3, 6, 9, 8, 7, and 4. And we'll continue to traverse down our matrix diagonally after collecting the first and second spiral and so on using the k pointer. So we say while k is less than m and k is less than n, and matrix K is not equal to V. And the reason we're doing that is we want to eventually have our program stop processing when it sees that a cell in the matrix has been visited. I use V for visited, right? And then for each traversal at the end of the spiral, we want to say I, J are equal to K. Right? And the reason is we'll start, if you look in example 1, when we start at 0, 0, when we increment k is going to be the thing that helps us go diagonal to increment the next spiral in the matrix. Okay, and so back to our code on line 10, we'll say while j is less than n and matrix I, j is not equal to v, to make sure that it hasn't been visited, res.append matrix I, j. Matrix I, j. And now we want to say that that cell, matrix I, j, is visited, v. And then we want to increment j, and when we exit that while loop, we say j minus equals 1, I plus equals 1. A lot going on here. So lines 10 through 13, let's take a look. So we're going across the row. If you look at example 2 on the left, 1, 2, 3, 4, and eventually we'll get to j equals n, which is outside the bounds of our matrix. So we have to bring it back. Now, of course, we've already seen 4 at this point, now that we brought j back, and so we need to go downward before we make our next collection. So we say I plus equals 1 in line 15. And ultimately, we're going to repeat this logic in a very similar fashion. We're going to repeat this logic 4 times. So 1, 2, 3, 4. And now let's edit it. Starting with lines 16 through 21. Let's take a look what that's going to be. So now that we've gotten across that first row, we want to now do the same thing column-wise, right? And the way we're going to do that is by incrementing I. So we say I, while I is less than or equal to m, as opposed to j is less than or equal to n. Okay, so do the same exact thing, res.append, and then matrix ij is visited. And now, instead of j plus equals 1, we have I plus equals 1. And eventually, as you'll expect, if you look in example 2, we'll go from 8 to 12, and then I will exceed the bounds of our matrix. So what we'll want to do here, as opposed to j minus equals 1, we need to bring I back into the bounds, and then we need to bring j to the left. So j minus equals 1. Okay, so now we've gone from 12 to 11. So now we're on 11 at line 22. Now in line 22, what ends up happening is that we need to change our logic again, except it'll look a little bit different. We'll say while j is greater than or equal to 0, because now we have to traverse left in that bottom row. Res.append matrix ij, same exact thing, but this time instead of j plus equals 1, j minus equals 1. J minus equals 1. And eventually we'll have 11, 10, 9, and that exits the bounds of the matrix, so we have to bring it back in. So j plus equals 1, and then I minus equals 1. I minus equals 1, because in line 27, right? And then in example 2, if we take a look, why we want I minus equals 1, we'll get to 9 again when we bring j back into the bounds of the matrix. We want to move up, and we'll have to move up to 5. Now the final while loop that brings us upward on the left side of the spiral that we're working on is going to be edited as well. It's going to look a lot like the one we just looked at. That's I is greater than or equal to 0, and matrix is not matrix ij is not v, so not visited. Res.append matrix ij, matrix ij is v, and now instead of j plus equals 1, we'll say I minus equals 1, because we're going upward. We don't need to increment this anymore, because remember, on the next iteration of this while loop, we'll say ij equals k, so k plus equals 1, and then finally we return res. We run, accepted, submit, outstanding.